analytics here in Raleigh, North Carolina. I graduated back in 2020, and since then I've been out working in different fields. So I've started in data science. I've recently moved over the last 7-ish months to be in data engineering. So I've been really focused in data engineering, done some boot camps, done a lot of reading, a lot of books, and just got back from Data Day Texas in Austin this past weekend, where we talked a lot more about data engineering and data. So some of you are here with a lot of experience. So go ahead and raise your hand if you're here with over 10 years of data experience, just data in general. I have one person here with over 10 years of data experience, right? 2, 3, okay, yeah, that's about 10 years. Yeah, we're right there. Okay, raise your hand if you got 5 years of data experience. Okay, we got a couple more. What about 1 year of data experience? IA, yeah, y'all got it. Y'all got at least 1 year. Come on. You went to the IA, that's like a whole year in and of itself. How about 0 year? You've never thought about data, not thought about data, you've never worked in SQL. Anyone that's never worked in SQL here? Okay. Anyone that's never worked in Python here? I think we got a couple maybe, don't want to raise your hand. But that's what I'm saying, we have a lot of experience here. We also have some new people here. I would say I'm on the newer side, but I do have some pretty deep experience. Right now, for example, over the last 7 months, I've been working in an enterprise-wide project, leading an enterprise-wide project to transition a Scala Spark, like a really complicated enterprise-wide Scala Spark pipeline into Snowflake SQL, something simple. So what I've done over the last 4 years is taken stuff that's really complicated and boiled it down to execs that don't really understand what's going on, or technical people who are seeing it for the first time who still kind of need a warm introduction to the material. So what I'm here today to do, and over the next 11 months, is take concepts that maybe are a little bit confusing or a little bit like I've never heard of that, or I heard of that and I don't really know where to start, and kind of boil some of those things down. And so today that topic is going to be dimensional data modeling. We are going to talk about why it's important too. We're going to talk about what the business might do with a data model after you produce some data model, right? What would you then, that's what we're working on even now with the client, right? We're going to build a new data model. What are you then going to do with this new data model? Everyone needs it. And everyone right now wants to talk about, I was talking to some of you about this, about LLMs and all these hot new things that are coming on the market. No one's ready for that. Like 5 companies out of 1,000 are ready for work at that level. What you're going to be doing if you move into data engineering, or if you're working as a DBA or an ETL developer or as a data engineer, a lot of the work you're going to be doing, we're going to talk about in this session and over the next 2 sessions after this. And if you don't know, this is a year-long thing. So after that, we're going to talk about data analytics in the Q4. Q3 is going to be data science, and Q4 is going to be ML ops. Sorry, Q2 is analytics. Q4 is going to be ML ops, a little bit of governance, and we'll have a big holiday party at the end of the year to celebrate all of you coming to all of these great events. So I do want to move in. Actually, before I do this, I'm going to do something that we used to do at PyData. So I used to go to a lot of PyData meetups here in the Triangle. They disbanded kind of when COVID hit, and I really enjoyed those meetups. So what I'm going to start doing at these is asking 2 things. Is anyone looking for a job, or is anyone hiring? And those are going to be the questions. So if anyone's looking for a job, raise your hand. All right, we have people here who are looking for a job. Normally I would say stand up and tell us a little bit about yourself, but that was a lot of people, so raise your hands again if you need a job. Okay? Anyone who's hiring? Also hiring? Okay. No. Anyone's hiring? Okay, no one hiring. We're going to do that throughout all the sessions. Sometimes there will be people who are hiring, sometimes there will be people that are not hiring. Like today, I'm sorry. I can't help you get a job, but that's what we're going to keep doing. Oh.
I fluttered my hand around.
Okay.
I'm not directly hiring from my team, but we're usually hiring.
Okay.
Just put my hand out to put my name out.
Great. So that's a great segue into who is Evan and why is Evan here. And it's important because Evan works for Elder Research. Elder Research is the company that's sponsoring this event. So they're located here in this building on the 3rd floor. They're a boutique analytics data science consulting firm. Yeah, that's what we would say. And they're a really great organization. So the founder of Elder Research is John Elder. And he connected with the IAA, or he connects with the IAA kind of every year, the master's program that I went to. And he's a really great person, has a great company. I really respect Elder. So if you do want to talk to Evan, I don't know, are you hiring right now, do you know? Or just like?
Not on my team.
Not on your team, but you know the company is hiring.
If you have a security clearance.
If you have a security clearance, okay, great. So
introduce yourself. happy to chat.
Yeah, for sure. Make those connections and can never hurt. And maybe Evan knows someone. Maybe Evan sees a LinkedIn post tomorrow and they're hiring and it's about the experience that you have. Who knows? That's what we're all here to do. So we'll move in now to the PowerPoint version of this. So where are you? This is kind of what I was talking about before. The Full Stack Data Workshop is a year-long program. We're talking about all of those things. I think I explained these things enough to you. The series is available both online and live in person, but not live online right now. That was a level of complexity I needed to keep out of this so I could just get this first one done. And then maybe I will add a live online modality, but that is not on my list of priorities at the moment. So if you ask me for live online, I'm probably going to tell you no. But it will be on YouTube afterwards, so I'm recording. That's why you see me in the bottom of the screen. That's why you see that 6:15 right there now. I am recording this. I will put it on YouTube. You will have this, because once we get to actually building the stuff, it's going to be, I'm trying not to move fast, but I usually move really fast. So you'll have the recording in case you need it. So we're talking about dimensional data modeling. Who am I? I forgot I had this in here. Great, I'm great. Thinker and doer, go Wolfpack, fails fast, wins fast, passionate about democratizing education. That's why we're all here. Zumba, I love Zumba. I do a lot of Zumba. Not a lot, but I do a decent amount of Zumba. I've been doing it for a long time. Mazapan is my favorite treat. And someone who wants you to win. I want the people who are here to learn something and to walk out of this saying like, yeah, that was cool. Like I want to go back. If you're a student, I'm not gonna ask you for money when you come back next time. If you're not a student, I am going to ask you for money when you come back next time. So sorry about that. Pizza is not free. Papa John's would not accept the fact that I was giving a free workshop to people as a way of paying for the pizza, unfortunately. Okay, cool. Yeah, so let's talk. That was a reminder for myself to get back on track. So what is data modeling? Why are we here? What are we doing? I didn't copy this from anyone, so it could be wrong. This is just like when I think of what data modeling is and why we do it. And if you talk to, I don't know, Joe Race or people that write books on data modeling, maybe they'll say, no, like he's missing something or you could add stuff, right? The whole thing, the whole workshop, maybe I'm missing something or maybe I could add something. But this, when I sit down with someone who's non-technical in my organization or with a client, this is what I'm trying to communicate to them. They also say that a data model is like the real world happens and it leaves a shadow, and that shadow is a data model. It's what you captured about a real world event. It's what you captured about the thing that happened, and it's how you capture it. The model is actually how we go about capturing those details of the things that happen. So it's our way of understanding the world through the lens of the business's data, and can represent work streams, reproducible framework for business to understand the process and create essentially order amongst chaos. It's also, you think about domain teams. So there's some organizations that'll follow kind of a domain-driven architecture, domain-driven design. And those organizations that follow a heavy kind of domain-driven, they can also fall into data mesh, and they'll also set their data models to kind of follow those domains. So your data models might have like a sales schema. In your sales schema, you might have all the tables that sales needs, and those are kind of like those one big table designs that will fall into. So a data model can oftentimes represent what's going on in the business or the topological design of the business. It's like once we actually get down to the logistics, that's how they're built. The artifact of a data model, what actually is the data model, is an entity relationship diagram, an ERD. You'll see one a little bit later in the PowerPoint after we go through and build everything. It's just a bunch of boxes and lines and things that just connect data sets to each other and make relationships, and it defines a one-to-one or a one-to-many, and there's a bunch of terms that get thrown around, but it's just how do the data sets talk to each other, and how do you pass context from one data set to another data set to get more information about the first data set. Is essentially what data modeling is. I do want to open it up. There are people here with a good amount of data experience, ETL experience, DBA experience. Anyone here that has some solid experience in this, or even not solid, just has other opinions about what a data model is to you? Got it. That means I explained it perfectly. That's really cool. We'll move on. Oh, man, I'm covering up this. Oh, go ahead.
One quick thing. Go back to the thing.
Yep.
One thing I noticed was you keep using the word business, understandably, but it could also be scientific or personal. You know, it could be that kind of thing.
Yeah, for sure. Yeah, I'm using business in the context, like this whole presentation is in the context of the business. But yeah, I mean, you could have something that you're working on, like your personal life could have a data model for sure. Yeah. Like anything that happens in the real, I like to say like, what we're gonna talk about today is fact and dimension. Like fact is a thing that happens, and dimension is a thing that describes the thing that happened.
It could be the time you think your battery's going to die in your car. You could have a whole bunch of stats on that.
Yeah, for sure. Anything that you like see in real life, like the shadow of the real world, right? Like anything that happens, we can define in a data model. It's just going through the exercise of actually defining what that data model is going to be. That's a great point. So why data model? Why not just throw all our data in a database like I'm sure most of your leaders would like to do, and then just have a good day? So what looks better? This is a little bit small, but that's just like that's just like a downloads folder on your computer. When you download, like when you're stalking someone's Instagram and you like take a screenshot and it's like what sends to your downloads folder, right? That's what that looks like. So how does that look compared to this, right? I mean, even that folder, even that image kind of sucks. But essentially it's just the structure of folders, right? Like how do you know when you download your tax return from 2018, like where it is on your computer, right? It's because you've set a hierarchy of folders that lead you right to where that file is. Unless you are chaotic evil and then you just have everything in your documents folder and you just know where it is. Like I've worked with people like that. That's terrible. I work with a lot of people like that. So that's that. And then there's a process to data modeling. Data modeling is not just one day I wake up and I write out this data model for this thing, right? We have to go through a process of saying we have nothing, how do we get to something? And this is those 3 steps of how we get to something. I would say going from nothing to conceptual data model is probably the longest piece of this, is a piece of this that requires, unfortunately, talking to other people and getting a really good understanding of the business and their pain points and some of the things that they're dealing with on a daily basis. So that our conceptual model really breaks out what needs to be in this table, what needs to be in this table, what needs to be in this table, how often do we have to capture the information in this table, how often do we have to capture the information in this table. The conceptual model is going to define each level of those pieces of information, and it'll create the relationships or the business logic, right? So that's the cadence at which we're describing it or capturing that information, describes the data, describes those relationships. It essentially is the shadow of the real world in its rawest form, right? It's like the 360p version of that shadow, where it's like, okay, cool, we got something on there, we've got it on paper, it's there, and we understand. We have the ERD, we understand how these data tables talk to each other. Now we have the logical model, right? Our 360p shadow now turns into a 720p shadow. We now have a little bit more detail, a little bit more. We had maybe some more meetings to get from a conceptual to a logical model. We discussed more with the business about like what that means, and also mapping the primary keys and the foreign keys. So we're going to map those keys probably at this step. And you could really it doesn't always get split out like this. A lot of times it could just get split out into like a conceptual model, but really that conceptual model is the logical model, and then you just move right into physical model. That it doesn't always follow the 3 steps. Businesses kind of cut corners wherever they want. Data people cut corners wherever we want. Like we have these rules. We oftentimes break these rules. They're just kind of like a general guide of how these things happen, right? Because the primary keys and the foreign keys also get tricky. And it oftentimes, once you created the conceptual model, and then you go to create the primary keys and the foreign keys, you realize that there's other things that you didn't build in your conceptual model. So it's like a way of checking yourself of like the work you built in that conceptual phase. You move into the logical phase, you create the relationships, and you're like, oh, like I needed another dimension table over there for like this thing, like that needed to be added in. And then the physical model is just like S3, RDS, like where are we putting this? What's the information? How do I put it in there? Am I loading it in with Python? Am I going to use Airflow? Am I going to use Prefect or Mage? Like what pipelining tool am I using to like get this into there? And then what are like the details of that? So it gets a little bit more into the systems that we're using in order to move our data. Like how are we moving our data? Like today we're going to use Python, but you might not always be using Python. You might be using Java or Scala, especially if you're in Spark, you might be using Scala. And so these are the details that usually come at this point, and also just making sure we're understanding, right, like the databases, the schemas, the tables, and the configuration information of all of those things. So it's kind of like the passwords and the secret keys. Any comments or questions, clarification points about what is a data model and this process of modeling?
So
is this process safe for big data like JSON documents, like graph data, things like
That's a really, really great question. So a JSON document being something that's just a semi-structured data set, unless I would imagine if you're moving it into a relational database, you would kind of go through this exercise, and that might happen in the physical model, right? When we get to say like, okay, this is coming in as a JSON. How do I parse out this JSON? Right? Like what? Like that's part of like the nitty-gritty detail. Like the source is a JSON, but the output is not a JSON. It's a relational table. But if it's going to stay as a JSON, it's going to stay as semi-structured. You're going to be in S3. You're going to be in your object store. You might have a data model with it, or you're going to have something that describes what that is for sure. You need a document. Like the whole point of this is like documentation. What is that JSON? How do I work with that JSON? Parse it out. But that's going to be a separate thing, right? A separate piece of documentation. And then the graph. That's a good question too. I would have to defer to someone else. That's not myself because I've never worked with a graph database. But I would imagine yes, because it has the vector embedding. I mean, a graph database itself has other things going on. Yeah.
Yeah, so like piggybacking on that, so like the JSON document that would be ingested into what will eventually become a data model. Like you wouldn't, how you say, like you might keep that artifact and then ingest it into a pipeline and then store it in what you consider a data model.
You can do that, yes. Or you could leave it as a JSON. Like you could it depends on especially when we talk about data engineering for machine learning, you might be passing a JSON payload right to a machine learning model. And so you very well could, like, that's what I'm saying, you need to document it because you need to know what that is, but it could just stay as a JSON because you don't need it to come out of as a model. Maybe you push that JSON to a model, and then what comes out of that model you then send to a relational database, or you send to a table. That could be how it goes. So you could keep the JSON, you could send it, like, in this we're gonna work with a JSON that's in one of our cells. So in one of these columns is actually JSON type, and we're gonna unpack that type today. So like you could even have JSON in your tables too. It's a long answer. I don't know if you even got to your answer, but detail. All right. Oh, yeah, DT.
I still don't understand the difference between a data model and a database.
Yeah. Yeah. Great question. So the database, think about the database as like, if the data model is the shadow of the real world, to me, like the database is the box that I then carry that shadow in with me. It's like the thing that is transporting my data model. It's the thing that allows me to even have that data model. Like it's what am I doing with it? Where am I putting it? Database is just like, if I create a connection to Postgres, I now have a Postgres database, right? So the whole database is like where everything is stored in that database. Yeah.
Consider that you have a form. It has a name field, a subject field, an email, and a phone number. That form is the data model. It's expecting your name, it's expecting your phone number, it's expecting your email. The database will be a file format of all of those pieces of paper that data stored. So like the paper defines this email is expected, the fields are expected, and the file format is the database where all that information is referenced. And you pull it from that.
Yeah, I think of the database as the implementation in the data model as the blueprint.
Those are great points. Awesome. To be completely honest, I forgot how these slides are ordered, so I have no idea what's coming next. What you see is I'm just as surprised as you are. Oh yeah, cool. So some important elements, like I said in this first bullet, this is not I said it earlier. This is, unfortunately, we have to talk to people. This is not an activity that you just do like type on your computer. Like, oh, I'm gonna like move this one into this table, and move this one into this table. Like, we gotta like talk to people. We gotta talk to sales. We gotta talk to product. We gotta talk to marketing. We have to talk to the different lines of the business to know, like, what are you doing? Like, how does your product operate, and how does data flow through your product, whether it's into your product, out of your product? How does your business actually function? And this is why data modeling, there's no like, this is how you data model. Like, that's why there's so many really smart people who have recommended completely different ways that are like best practices for data modeling. You have people like Bill Inman who have just said like, never capture history, put everything in a data warehouse and put it into a mart and be done. And you people like Ralph Kimball and the star schema are saying like, no, we need like fact tables and dimension tables. You have people that do one big table, which is really trash, but like it will build a hybrid structure on that, and so it's not always trash. But there's really smart people that have done this, and there's never really like one consensus on it. And when you have really smart people that can't come to an agreement on something, that means it's a hard thing to do. And so data modeling, that's what it is. What I like about dimension and fact modeling in like the Kimball and the star schema is referencing back to what Jeff Bezos calls a two-way door. When you make a decision, you can easily undo that decision. And by easily in the enterprise sense, it's like a month instead of a year, or 2 months instead of a year. Like easily in the enterprise sense is still not necessarily easy, but it's easier than what it might be otherwise if things were really like monolithic and really tied together, and you didn't have a data model. It might be really hard to undo some of this stuff. So like what I'm saying here, the flexible data model allows us to add in one metric to our visualization, and that doesn't catch the whole company on fire, right? Like we can just throw that in, we add that to our pipeline, and then we're good. Like everything's done. Like the data model was there, the data was there in our staging zone, it just wasn't in our publishing layer. So all we did was we moved it to our publishing layer. The BI tool knew to add that new column in, and we built the new visualization on top of that column. Great, we're done. Like that's it, it's the whole thing. And if we didn't have that in there, if we're following like a one big table structure or something, then that would be a really hard task to do. That would not be just like add that column in. It would be, we have to go back and source that data because this is our truth. And if this one table is our truth, then we have to go all the way back to the beginning and add that all the way through. You were hanging your head up, Chuck?
Yes. Dimension and fact modeling.
Yeah. We'll come to that.
Okay.
Yeah, sorry. I jumped ahead a few times on the part, so we will come to that. And what I was talking about, really smart people, there's no one way to model data. There's many schools of thought school. So we're talking about Kimball data modeling here, or star schema, because that to me has been the thing that's used most in industry. It's the thing that I see most over the last 4 years that I've been doing this, not 20. Different types of data modeling, we'll talk about it a little bit. So Bill Inman is the father of the data warehouse. Ralph Kimball kind of coined star schema or Kimball model. OBT is one big table, and Excel databases. Just leave that there. Don't do that. Someone said today they did that, and I just had to not like cry while they were telling me that, but they were like, it's the best I could do. And I'm like, please don't tell me that. And so we're gonna talk about Kimball here, but I wanted to throw them out. I'm not gonna discuss Inman. I'll discuss OBT a little bit. I'm not gonna discuss Inman here. If you wanna go like read more into what like Bill Inman talks about in data modeling, he's great, super smart guy, like just has a different view on data modeling. Like he's really talented and a lot, like people really agree with his approach too. It's just a different way of doing things. So Kimball data modeling, star schema. What is the fact? What is the dimension? Fact, the thing that happens. Dimension is context, the thing that happens. So, thing that happened, I gave a workshop today. Dimension of thing that happened. The workshop happened at 14 East P Street in Raleigh, North Carolina. And then like, what occurred, and that's actually still a fact because it's still it's the tie to the event itself. But then if we say 14 East P Street, what would be the dimension? That's a dimension. We would go into our dimension table, we would find 14 East P Street, and there would be a bunch of attributes about this building. It's 3 stories, it was built in this year, 4 stories, I don't know. It was built in this year, it can have this many inhabitants, it has this many rooms in it, it has this designation, like corporate versus residential designation, and like the zoning laws. Like that would be information about 14 East P Street that is not tied to this event. Like that is stored separately because I don't need every event that happens at 14 East P Street to also contain information about that this building was built in 1950, has 4 stories. Like I don't need that repeating in all the rows of my data set. I just need that in one spot that I can reference back to whenever I need it available for a BI tool or for regulatory reports or for auditory reports. Like maybe I need to pull back that information somehow. It doesn't need to be in every row of my fact data. And that way, if there's 4,000 events that happen at East P Street over the next 5 seconds, now we're talking like enterprise level stuff, there's a lot of room saved in our database, and we just do a join, we reference back to it whenever we need it. So that's essentially what a fact in a dimension table is.
Also, you risk not changing, not to the data, not making sure you have to change it one place,
Yep.
not 20 or 30.
Yep, because what if they build another floor of this building? Okay, well now instead of 4 stories, it's 5 stories. Okay, now I have to go back to 6 billion rows in my table and update 4 to 5. Like that sounds like a really intensive and unnecessary operation, whereas I can just go into my dimension table, find this address, change that 4 to a 5, and I'm done. Like that's it. That's all I gotta do. I don't have to do it in every single row that this thing appears in. All right, what are we gonna do today? So, like I talked about, I've already gone way too long in terms of like what I expected to talk about in this part, but I did want to introduce everyone to this. So what we're gonna build today, we're gonna do a little flow. So I did generate some fake data, and that might be something that you might not be able to do right now, and that's okay. Really, we're gonna dive in and talk about, I have like a data camp model. I can remember that word. Thanks, Brad. Data camp model where I just have most of the stuff built out, and it's just gonna be fill in the blanks. So that way we don't have to go through and build all the scaffolding around the SQL code. Everything's ready. We're just gonna fill in a couple blanks, and that's gonna force us to talk about each one of the cells and what's going on. So you see, we'll generate the fake data. We're gonna land those. So these are gonna be e-commerce point of sale transactions that we're landing into the transaction table in the landing zone. Then we send that to different tables. So the 3 that you see there, those are dimension tables: event type, payment type, and product type. And then we have 2 fact tables: transactions and transaction details. 2 different fact tables, so different granularities on our fact tables. And if you 2 fact tables with the same granularity, they could probably be the same fact table. Sometimes they'll need to be separated out, but a lot of times if you have 2 fact tables capturing a lot of events on the same granularity, you can find a way to put them together. So that's what we're doing. Those have 2 different granularities, and then the dimension tables are going to describe those. So we'll talk about that. We're going to build the beginnings of a conceptual model in duckdb in Python. Don't be scared if you've never used duckdb, but it's a really cool tool that if you've used Python before and you've used like SQLite 3, it's just like SQLite 3 except so much better. That's really all it is. It's just an engine, a SQL engine that you use in Python that allows you to do more data-like type operations. So also something I'm focusing on here for anyone that's like ETL or DBA. I'm not talking about relational databases. I'm not talking about working in Postgres or MySQL. I'm talking about S3, Google Object Store, Azure Blob Storage, like things you would do in there, because that's where we're going. Like that's where the industry is going. That's where we're going. If you know these things, you know enough about relational data, and your company's probably pulling its data out of relational databases anyway and moving them into cloud databases or cloud, or at least S3, where it's just you land it in there and they figure out what to do with it later, right? You're probably moving in that direction if you're working in data, and so you don't really need to know the details of working in Postgres or working in MySQL. We will talk about Postgres the next 2 sessions a little bit more, because that is the main like RDBMS tool that we're going to use, that most people are using. If they're using like RDBMS, or using MySQL, PostgreSQL, Microsoft Server. There's a lot of different tools you can use for relational tools, but we're not focusing on that. Focusing on the data lake, because that's what's common now. See, all right, time to code, time to build some stuff. It's going to take me a second here to get over to that screen. I'm going to shut the recording down for right now and come back on the recording once we're on the coding screen.